Assalamu alaikum everyone. So today we are going to sorry, we are going to do the ATP paper basically. Okay. Okay. So today we are going to do 5070 paper 42, which is alternative to practical, May June 2024. Okay. Let's move to the question number 1. So a student finds the amount of iron 2 ions in the solution by titration. The student uses a volumetric pipette to add 25 centimeter cube of aqueous iron 2 sulfate to a conical flask. Add approximately 20 centimeter cube of dilute sulfuric acid to the flask. Slowly adds aqueous potassium magnate 7 to the conical flask until the solution turns pink. Repeat the titration several times. So see, that is not acid-base titration, that is a idiometric titration, and in these titrations, students, we don't use indicator. Do remember this, okay? And is we use the acidic medium, and then we add uh, potassium magnate. So potassium magnate is filled in the burette, and at the end, we will get the pink color. So that is how we can perform this titration, okay? Now, uh, figure 1.1 shows the apparatus the student uses to measure the volume of dilute sulfuric acid. Name the apparatus shown in figure 1.1. Yes, what is the name of this apparatus?
Measuring
Measuring
cylinder.
cylinder.
Measuring cylinder. Okay. Then part 2, explain why the student does not need to use volumetric pipette to measure the volume of the dilute sulfuric acid. So the thing is that if you read, the actual titration is between iron 2 sulfate, iron 2 ions, and the aqueous potassium magnate. And so if you recall from the oxidizing agent test, we use acidified potassium dichromate, potassium magnate. So the reason behind this that we doesn't need it accurate, because we just need it to provide the acidic medium. So there is no specific or accurate amount is needed. So acid only needed to provide acidic medium, because the oxidizing agent works in the acidic medium. Whenever you see the oxidizing agent behaving as an oxidizing agent, it is always acidified potassium magnate 7. So acidic medium, hence its accurate amount is not needed. Is this clear to all of you?
Yes, sir.
Now describe how the student uses the volumetric pipette to measure 25 centimeter cube of iron to sulfate safely. So whenever it comes to safely, what we are going to use, we are going to use pipette filler, as we have discussed earlier, because with the help of pipette filler, it avoids that the liquid entering in our mouth. Otherwise, we need to suck it from the pipette as we do with the straw if there is no pipette filler. So uh, use or there is another apparatus called safety bulb. So either you can write pipette filler or you can write safety bulb. Okay. Now, Part B. Name the apparatus the student uses to add aqueous potassium magnate to the flask. So as I have told you, potassium magnate has been filled in. We are adding slowly. So we are adding dropwise in the titration. The solution which we added at the last, that is always filled in.
Purate.
Purate, that is always filled in. Purate. So purate. Now, part C, state why the student does not need to add an indicator to this titration. Because the potassium magnate solution changes the color. It's purple and it goes colorless. So at the end, the solution turns pink. It turns pink because all of the iron 2 has been oxidized and all of the magnet has been used up. So when the next drop enters the solution in the flask, it is now no more iron is there to react with it. So it doesn't react, instead it just diffuses. So the purple color diffuses and as a result, we will get the pink color. I hope it's understandable to all of you.
So can you explain one more time?
Yeah. See, when the potassium magnate reacts, its color goes from purple to colorless, right?
Yes.
So in titration, when we are adding it dropwise into the conical flask where there is a iron 2 positive. So when it enters in the conical flask, it reacts with the iron 2 positive. As a result, iron 2 positive is oxidized and magnate has been used up, right? So
Yes.
assume that after some time when you added the drop, at that drop, all the iron 2 positive has been oxidized. So, and the magnet goes colorless. So now if you are going to add the next drop, what is going to happen? Do that next drop is going to react?
No.
No. So it is a purple color, right?
Yes.
So instead of being reacting, now it stays, but there is a whole lot of colorless solution and that purple drop diffuses in it, it gets mixes and as a result, the whole solution goes pink, indicating that the titration has been completed. Is this clear?
Yes, sir.
Okay. So potassium magnate changes color. Now, D part, explain how the student knows when they have done enough titrations. So as we know, we have seen earlier, uh, so we are going to take the titrations with the difference of a 0.2 centimeter cube. So at least we need two of the titrations with the results of 0.2 centimeter cube. At least two titrations with the difference of 0.2 centimeter cube.
Sir, how is it 0.2?
Because if you see in the previous ones where we have ticked the two titrations, if you recall, for example, no, not this one. See, the closest one with the difference of a 0.2 centimeter cube, isn't it?
Yes.
Okay. So we need at least two titrations which have a difference of 0.2 centimeter cube. Okay, now question number 2. A student investigates the temperature change when a solid completely dissolves in water. The student measures 25 centimeter cube of distilled water and pour it into a beaker. Okay. Uses a thermometer to measure the initial temperature of the water in the beaker. Record this temperature in the table 2.1 at time is equals to 0 degrees 0 second. Okay. Add a sample of the solid to the beaker and restart the stopwatch. Stir the mixture, record the temperature and time at 60 seconds interval for a total of 300 seconds. Okay. Some of the results are shown in table 2.1. Okay. Figure 2.1 shows the results for 120 seconds and 300 seconds, and these two are missing in the above table. So record the values from figure 2.1 to the nearest of 0.5 degrees Celsius in table 2.1. Okay. So if you see this one, this one is 11, 12, 13, 13.5, right? That is at 120 and 300, it's 15. So 13.5 and 15. Okay. Now calculate the maximum temperature change in the investigation. So the lowest temperature is, if you see, no, 1 minute. That is the highest temperature. And if you see, the lowest one is this one, right? So the greatest temperature change would be the highest temperature minus lowest temperature. So it is going to be 19.5 minus 13.5. So on subtracting these two values, you will get the result of 6.0, right? Is this clear to all of you? Now, next part. Describe the trends shown in the results in table 2.1. Okay. So from table 2.1, what we have seen that initially the temperature decreases, right? And then it increases.
So shouldn't be the
So
change 6.5?
yeah, it's 13. Yeah, sorry. Thank you. So it's 13. 19.5 minus 13 is 6.5. Thank you, Abdullah. So, okay. Initially, the temperature decreases and then it increases. Okay. Now, next part. Suggest the temperature of the mixture if it is left for 60 minutes. So 60 minutes. And over here we have just done for 300 seconds. So again, so see, if we leave it for so much time, the temperature again reaches to the room temperature, which is over here 19.5 degrees Celsius. So they are asking to explain your answer as well. So first I'm mention the temperature that it is 19.5 degrees Celsius. Uh, as the reaction was finished, hence the temperature reaches to, either you can write initial temperature or you can write room temperature. Is this clear? Now, describe the energy change when the solid dissolves in water. Explain how the results in table 2.1 support your answer. So if you see the energy change, the temperature is going down. So it means the energy change is going to be endothermic. And the explanation. How could we know that it is endothermic? As the temperature decreases. Is this clear to all of you? Now, next part.
Sir, can't we see that the heat is absorbed from the surroundings?
But how could you know that the heat is absorbed? The evidence is that there is a decrease in temperature. That's why the heat is absorbed. So if you write the heat is absorbed, so again you have to second that by mentioning that it is because it is observed as the temperature decreases.
Okay.
Okay. Now, C part, explain why it is important for the student to stir the mixture. So so see, we are stirring, so it helps us to ensure that the whole solution has the same temperature. And the other thing, we have added the solid, so to ensure that all the solid get dissolved. So you can write any one of the option. Ensure all the solid gets dissolved, or the whole solution uh,
Sir, if the experiment is
Simple.
not temperature related, then we don't have to mention temperature in our answer.
Yeah, if it's not related to the temperature, then there is no need to mention it.
Okay.
Okay, next part. The maximum temperature change calculated is not true value for this investigation. This may be because the volume of the water and the temperature are not measured precisely. Explain how to obtain the most precise temperature measurement. So if they see, they have mentioned that they want you to get a more precise temperature measurement. So you are going to use a thermometer with the more graduations, which
Sir,
is
can
more
we say
graduated, which has a
digital
more,
thermometer?
yeah, you can use a digital thermometer, can be accepted as well.
Okay.
Digital thermometer or thermometer with more graduation.
And sir, how would we measure the volume of water precisely?
You can use a burette or a pipette,
Okay.
more graduations. So these are having a graduation of 1 degree. So we need a one having a graduation lesser than 1 degree Celsius. Next part. The maximum temperature change calculated is less than the true value for the investigation. Suggests the reason for this, other than the precision of measurement, describe an improvement to the method which reduces the error. So it's very simple. The reason is, if you see that there is a always the heat is either lost to surrounding or gained from surrounding. So if the heat is being gained from surrounding because it's an endothermic reaction, so beside the energy being absorbed from the reaction, it is also gained from the surrounding as well. And for that, we have to do it. We have to do insulation or put the lid on the beaker. So heat gain from the surrounding. Put the lid on beaker, or instead you can use a polystyrene cup as well. Now, question number 3. A student does a series of experiments to investigate a solution R. A1. The student leaves a wooden splint with one end dipped into the R for 10 minutes. The student then places the damp end of the wooden split into a flame of a Bunsen burner with the air hole open. So when you have an air hole open, it gives you the blue flame. The student concluded that the R contains sodium ion. State the observation which allows the student to make this conclusion. So if you go over here on the flame test, so if it's a sodium, so I think it's a yellow.
Yellow flame.
So yeah, sodium, it's a yellow flame. Very good, Abdullah. So yellow flame. Next, explain why the air hole in the on the Bunsen burner must be open when doing this flame test. So the flame of the Bunsen burner goes blue. So
Sir, I've seen questions where they ask, why isn't a yellow flame used?
it has a lesser energy. It is due to the less incomplete combustion. It gives you the lesser energy.
Okay.
So the flame of Bunsen burner is blue. Now, next B1. The student adds dilute nitric acid to R. The student observes effervescence of a colorless gas which turns lime water milky. State the conclusion from these observations. So, CO2 liberated because the lime water goes milky. So, it means that R contains carbonate ion. Is this clear?
Yes, sir.
Okay. Next part. The student adds aqueous barium nitrate to some of the mixture from B1. The student concluded that R contains sulfate ion. State the observation which allows the student to make this conclusion. So if you recall, for a sulfate ion, it is always white precipitates on adding barium nitrate. Now, part third, the student adds aqueous silver nitrate to some of the mixture from B1. The student observes a colorless solution. State a conclusion from this. So silver nitrate has been added to identify the chloride, bromide, or iodide. So if we didn't get any observation or any precipitate, so it means no chloride or bromide or iodide.
Sir, can we just write halide? No, there are no halide
Yeah, you can
ions.
just write no halide ion is present as well. Now, part 4. The student adds aqueous sodium hydroxide to R and warms the mixture. Describe a test and observation to show that R does not contain ammonium ions. So, we use the damp red litmus paper If you recall, on heating, if there is an ammonium ion, the ammonia gas liberates and we use a damp red litmus paper. And if there is ammonia gas comes in contact with the damp red litmus paper, the damp red litmus paper turns blue. But over here, as there is a no ammonium ion, so when we use the damp red litmus paper, it doesn't going to change. So the observation would be no change. Is this clear to all of you?
Yes, sir.
Okay. Now C part, solution R is made from a mixture of two different ionic compounds. That is the name of these two ionic compounds. So if you recall, we have identified that there is a sodium ion. We have identified that there is a carbonate ion. We have identified that there is a sulfate ion in it, isn't it? See, no bromide, chloride, or iodide is there. White precipitates due to the sulfate ions. There is a carbonate ions, right? And there is a sodium ion. So it means one cation and two anions. So the compound would be the both the compounds are of sodium. So it is going to be sodium carbonate and sodium sulfate. Is this clear?
Yes, sir.
Okay. Now part D. The student tests a different solution P and finds it difficult to decide whether the solution contains chloride ions or bromide ions. The student also has a potassium chloride and aqueous potassium bromide. Suggest how the student could use the aqueous potassium chloride and aqueous potassium bromide to make it easier to decide whether P contains chloride ions or bromide ions. So it's easy. You know you have a potassium chloride and you have a potassium iodide, right? Okay. So add silver nitrate aqueous to potassium chloride and potassium bromide. So chloride will give us the white precipitate and potassium bromide will give us a cream precipitate. Is this clear? Yes. Then what we are going to do, we are going to add silver nitrate to solution P. Now what we are going to do, we are going to compare the P compare the precipitates would form. So to compare the color of precipitates formed with P with the rest. So the precipitates of P either matches with the potassium chloride or potassium bromide. So that's how we can able to figure out whether it's a bromide or a chloride. Is this clear to all of you?
Yes, sir.
Yes.
Okay.
Yes.
Now, E part. The student adds dilute hydrochloric acid to another solution and a gas is produced. The gas is passed through lime water. Describe how the gas is passed through lime water. You may draw a label diagram to help answer the question. So, as we have discussed this type of a question
Using a
earlier in the
delivery.
previous past paper, use a delivery tube from the container in which reaction occurred. You can call it reaction vessel as well. and bubbled the gas formed into the lime water. Is this clear to all of you?
So instead of
Yes.
container, we write test tube.
Yeah, you can write reaction vessel. You can write reaction, the test tube in which the reaction occur, the beaker, the flask in which the reaction occur. Not use beaker because beaker has a very open mouth, so the
Oh.
gas escapes away. You can't close the whole mouth of the beaker, opening of the beaker. Okay. Okay. So we are end with the question number 3. Now
Okay.
we are going to start question number 4. The copper 2 carbonate reacts with the dilute sulfuric acid at room temperature. The word equation for the reaction is shown. We have a copper 2 carbonate reacting with the sulfuric acid, forming a salt, carbon dioxide, and water, right? Plan an experiment to determine the volume of carbon dioxide formed when a known mass of copper 2 carbonate completely reacts with the sulfuric acid. So see, it indicates that we have to keep this sulfuric acid in excess. Volume of carbon dioxide, so we are going to use a gas syringe because carbon dioxide is a gas. Okay. Your plan must, and weighing balance as well, because we need to know the mass, how much mass we have used. Okay. Your plan must include some of the use of a common laboratory apparatus, dilute sulfuric acid and copper 2 carbonate. Okay. No other chemicals should be used. Your plan must include the apparatus needed, the method to use, the measurements to take, the procedures to ensure the volume measured is as accurate as possible. Okay, you may draw a diagram to answer the question. Okay. So, as we are producing the gas and collecting the gas, right? So, we need a conical flask, right? And we are going to need a gas syringe. Is this clear to all of you? So first, what we are going to do, weigh and record the mass of copper 2 carbonate place it in conical flask, add excess of dilute.
So your screen is stuck.
1 minute. Is it still stuck? Okay, is it clear now?
Yes.
Okay, add excess of dilute sulfuric acid. Put the bung quickly, which is connected to the gas syringe. Measure the volume of carbon dioxide gas formed Till here, is this clear to all of you? Now, for the accuracy, wait. For example, the reaction occurs, those are the bubbles form, so we have to wait till all bubbles stop forming. That would indicate that all of the gas has been collected, right? And further, what you are going to do, you are going to repeat and take the average to make the results more precise and accurate. Is this clear to all of you? Any confusion so far? So here we have ended the paper. So if you see, these paper are easy and it's a scoring paper.